Alright, okay, alright. See. Righty mighty dighty. Okay guys, welcome. It's been a second. I won't say it's been a minute because it hasn't been a minute, it's been a second. I hope you guys are well. I hope you've had a good week. Maybe in the comment section we can just indicate if firstly is the are we hearing me very well? Network connection okay? Just let's confirm that first before we can get into the exciting things that are lined up. And yes, this is for grade 11. No other grade but grade 11. Grade 11s should be joining me as of now at the moment. So unfortunately, sorry my grade 10s, not you. I don't want you. And I don't want the grade 9s, and I don't want the grade 8s. The grade 8s and the 9s can actually go and do whatever they were doing. I don't want you here. I just want the grade 11s. So grade 11s, I hope you're good. I hope you're well. Maybe you can just comment in the comment section as to like literally what topic are you busy with at school at the moment. Now the thing is, that's not going to inform what I'm going to do in the live. In the live, I'm going to do what I have planned. And we've been going systematically through topics. So basically, I am today going to do something called how to find a quadratic equation from roots. And then also I'm going to transition into real and undefined, just to sort of like have a bit of a conversation, if you will, about that. And then we're going to look at something else that can basically put a spanner in the works where roots are concerned. Okay. So like I said, I'm not asking you where you are at school so that I can address that thing. No. I just want to check, what are you guys currently doing at your respective schools as a grade 11 learner? What topic are you guys at currently, like as in like now? The last thing you did on Friday, or if like your teacher is pulling Saturday and Sunday classes or whatever the case may be, like where are you at the moment, like as in like right now? What topic, which section, okay, are you guys in? Right. So I see Ulwandle says they are on third equations. Precious as well is saying third equations. You could swear that Precious and Lwandle are in the same school. Kabelo R. Scott is saying we are still doing thirds. Sia as well, exponents and thirds. All right, nice. Very nice. Okay, so it seems like a large majority of us are doing exponents and thirds and all of that beautiful and amazing stuff. All right, so based on what you've just said to me, are there any challenges that you guys are experiencing currently with those thirds and the equations and all of that stuff? Okay, because most of the work we've done here made me feel like a genius at school. That's brilliant. I love hearing that. Like you don't know Luandle, how much that makes me feel like so good. You literally it's almost as if like you've literally placed, I don't know if like that feeling actually even equates to what I'm feeling right now. Yeah, that comment in and of itself embodies the whole purpose and point of why I, started these sessions early for you guys, because I wanted you to start having that feeling, that genius feeling that you're having at school, simply because you feel like you understand the work, and plus on top of that, you can actually execute like all the steps in the way that they ought to be done, and the maths is just making a lot of sense. And you actually even feel like you want to tackle even higher order questions. That's exactly what I was gunning for, and I was hoping that I would achieve by actually having these early sessions with you guys. So you're benefiting a lot because of that. So thank you for that comment. I really appreciate it. Like I said, I wanted to actually put value. I wanted to equate it to sort of like receiving monetary value for that, but like it doesn't really equate, because yeah, it's something even bigger than for me the feeling is just it's surreal. So thanks for that. Thanks for letting me know, Lwandle, about the impact. The impact. I've been appreciating some of the people. Like I actually had another learner, but like it was more of like on WhatsApp. They sent me a message yesterday, and they said like it was practically a voice note, and the learner was saying, "Sir, I can't thank you enough. Like I feel like I'm actually so ungrateful, because to be honest, like I feel like all the sessions that we've been having like the past couple of days before even school started, like they're helping me so much, like, and in actual fact in school, like I feel so good about the maths, and I'm like, yes, that's great, that's exactly it, like that's it, guys, like I mean that's what I wanted. So I'm happy. That truly helps me. Yeah, that makes me happy a lot. Cheho, hi, hello, and hi to everyone else who's slowly but surely joining in the live. Thank you so much. And Lwandle, you are appreciated as well. The comment in and of itself, like, I mean, you could literally say that that is basically my evening made. Um, yeah, no, that's good. I really am. I'm very happy, and it's not that I'm actually. I don't know. It's not like I was anticipating that people would come and you know thank me or whatever the case may be. It's not like it's the gratitude in and of itself that's making me uh, like I wasn't doing that so that I could get the gratitude at the end. No. I mean, like I said, this is just simply me being me. So I'm happy that it is actually helping and it's having an impact, positively so. So great stuff, great stuff. So guys, just continue pushing. Like I said, I have said many a times to you guys, you already have access to the live lessons that I've done. I've been really struggling with certain of the live lessons that I've done to actually like extract them from TikTok and actually upload them onto my channel, some of the videos. Today I was actually battling with like getting my grade 10 video yesterday. But I did eventually, but like it just needed me to like persist and try over and over again. So I eventually am able to, and like I hope to be able to get all of those videos onto that YouTube platform so that you guys can have access to those and actually watch them as you want, when you want, however you want. Yeah. Funny thing is, I saw a video today, and I think I'll just say this as well. Kevin Maths and Science. I saw an ad video on YouTube. Kevin Maths and Science has apparently lowered his prices of access to his like material and videos that he has done for the past few years. He's actually even like amassed many of his videos that he's done over the years, and he has now made those available at a price, I think it's 85 Rand a month. He actually is making that available to everyone and anyone who would want to actually just have a grip over the maths content. And I mean, you guys should know, if you know Kevin Maths and Science, I'm sure you guys have been exposed to his content. His videos are really good. I mean, these are some of the great giants, I feel like, that are on social media and platforms that are actually making available like maths content and making it so easily and freely available for everyone. So now like he's lowered the prices from a big, I think 300 and something Rand to an 89 Rand a month. So I think you go to his website, it's 75 Rand. Wow, Rick, that's even better than that. That's even better than what I heard then. So he's making that available, and I mean, he even says that if you feel like you are good and done, like whenever you feel like you want to discontinue the thing, you can discontinue it, and then stop having the monthly deduction happening. He's pretty much making things available. Okay, Kevin Maths and Science, guys. Kevin Maths and Science. So yeah, these are people that have been here longer than I have been, and like he is amazing. He is phenomenal. I like the fact that his video content is very, I could say it's very appealing to the eye. He's good. He's really good. That is Kevin Maths and Sciences, guys. And I just wanted to, put that word out there. Him and I are not friends, but I do really value the work that he does and the impact that it is having in the country. I have a learner, for instance, from last year, who is one of my learners that has gotten he got 7 distinctions in his NSC metric last year. And he is also someone that has benefited greatly from just watching YouTube videos that Kevin Maths and Science puts up. And it's really impacted his maths performance like nobody's business. This boy now is going to do, I believe, actuarial science at the University of Pretoria. He was placed number 2 in the district where I reside. And I recently just uploaded a YouTube video of his where he was actually sharing his experience. Together with that, he was also attending a very amazing maths program for maths and science called Kutwanong. And that also really helped impact him greatly, holistically, for all of his subjects, because they also have a platform that's available to assist learners generally. So guys, this is all, I think, just resources that are available for all of us. We can, like I said, utilize those, but I just wanted to say that. And yeah, let's get into what we have today, though. Let me sort of move away from all of these beautiful resources that we have. It's grade 11, guys. It's grade 11. It's grade 11. It's grade 11. Welcome to the platform. Welcome, grade 11. If you're on grade 10, well, I did a session with the grade 10s yesterday. We were doing how to simplify algebraic fractions. That video that I did, that live video, has been uploaded now on my YouTube channel. You can check it out. Grade 12 will shortly be after this grade 11 session, Asake. We will be continuing on with sequence and series with the grade 12s after this session, though. Okay, let's go grade 11s. Alright, so here we are. Find a quadratic equation from roots. Do we still remember what a root is, guys, according to my YouTube channel's name? You can go onto my bio, my friend. But it's all capital letters. Maths is a game. But you can go to my bio. There's a link, not the WhatsApp channel, the YouTube channel. That's where I upload the live videos that I've done so far. And we've pretty much covered everything up until what I'm doing now for term 1. So exponents and surds, including the introduction of equations and inequalities and all the other things up until now. So today we'll be looking at finding a quadratic equation from roots. Do we still remember, guys, what a root is according to maths terms in algebra? Do you still remember what a root is, guys? I'm not talking about life science here. I'm talking about mathematics. Do we still remember what a root is? Hey, look at this. Yes, I will be musical Mosha. I will definitely musical Mosha. There I am, with my Xhosa tendencies. I'm musical Mosha. Yes, I'll upload this on YouTube after I'm done. Do you still remember what roots are, guys? Seems like everybody's evading the question. People are not actually looking at the question. Precious and Jude are having a nice time there in the comment section. Must I switch off my comment section so that you guys can focus? Alright, guys. We forgot. I'm hurt. Hurting me, hey? Roots, guys, are the solutions of an equation. Let's not forget that. Okay? A root in quadratic equation terms, or in solving for x terms, A root is a solution of an equation. That's what a root is. Okay, let's not forget that. Okay, so what is the topic today? It's saying find a quadratic equation from roots. Okay, so how do we find an equation when we have been given the roots? This is basically what we are going to be looking at today. So we're going to first look at type 1 of these kinds of questions. And please stay with me. So Kabelo Scott, I'm hoping you now remember what a root is. Tlotlo, I hope you now remember what a root is. A root is simply a solution of an equation. So whenever you are given an equation and they like solve for x, and then you get those beautiful answers at the end and you say x is equal to or x is equal to, those are called roots of an equation. They are the solutions of an equation. Okay, and that's what we refer to as roots. So hopefully we're on one page. So let's look at type 1 of these kinds of questions. So the first question that we are asked is, give one root. When we are given one root, okay, so type 1 of these questions is when we are given one root and we are asked to find an unknown and the other root. Okay, so like I'm going to repeat again, the first type of questions that we're going to look at is when we are given one root and we are asked to find the unknown or the other root. Okay, the unknown and the other root. We are actually asked to find the unknown and the other root. So let's look at an equation or a question, sorry, not an equation, but a question that basically covers this type, where we are given one root and then asked to find a particular unknown and one other root. So let's look at one question that has that sort of like makeup. So this is saying if one root, this is example 1, if one root of an equation, please look at the equation, 3x squared minus x plus k is equal to 0 is negative 1. Guys, I repeat, if one root of an equation 3x squared minus x plus k is equal to 0 is negative 1, find k and the other root. Guys, I hope we are hearing this. If one root of an equation 3x squared minus x plus k is equal to 0, and this is an equation, guys, is negative 1. So this is one of the roots. One of the roots is what? Is negative 1. We are asked now to find k, which is basically this unknown variable, and the other what? The other root. Now you're probably sitting there and you're like, okay, first and foremost, they are giving me an equation. This equation does not have the actual value of the constant term, but the actual value of the constant term is hidden. It is unknown to us, and it is represented by this letter k. But we are told what one of the roots of that equation is, and the root of one of those equations is actually negative 1. Now we are being asked to find the value of k and the other root. Now you're sitting there and you're like, how is it that they can ask me to find the other root? I mean, I have one root. How is it that they can ask me to find the other root? Are there two roots to this equation? And the thing is that you can actually conclude that yes, 3x squared is a quadratic equation. And remember, any quadratic equation, x squared being your highest degree of the exponent, should typically have what? Two solutions, as represented by the exponent that is the highest degree for this equation. So where do we start? Once again, if one root of an equation, 3x squared minus x plus k is equal to 0, is negative 1, let us unpack this. One root is negative 1. What does that mean? It means x is equal to negative 1. I hope you guys are with me. One of the roots given to us for this equation is x is equal to negative 1. But we are just told is negative 1. But because we know that this is a root, it therefore means that x is equal to negative 1. Furthermore, the equation that we have been given is 3x squared minus x plus k, which is equal to what? 0. What is this? This is the root of what? This equation. So if it is the root of this equation, if x is equal to negative 1 is the root of this equation, then it stands to reason that I can substitute x is equal to negative 1 into the equation. Why? Because x is equal to negative 1 is a root of this equation. And remember, I have a mission, and the mission is I need to find k. So how am I going to find k? Because that's my first mission. I need to first find k. So the fact that this negative 1 is the root of this equation, it means I can take x is equal to negative 1 and substitute it into this equation. So that's exactly what we're going to do. So 3 in the place of x, we are going to substitute what? Negative 1 in brackets. Let's not forget that. We square it. Minus negative 1 in brackets because there's another x there. Followed by what? Plus k equal to what? 0. Guys, I hope you're feeling this. All right. And this is simply us utilizing the information given. We were told that negative 1 is a root of this equation. If it is, then it means we can take x is equal to negative 1, substitute it into this equation, and then in that way be able to do what? Find k. I'm sure you guys can see that now we only have one variable, and that variable is what? It is k. So let's go ahead and solve. 3, remember that BODMAS says that negative 1 squared receives priority, so we apply the square to the negative 1, we get positive 1. And obviously 1 squared is just 1. Okay, and even exponent changes the negative sign to what? To positive. That's very important inside the bracket. Negative times the negative is positive 1. We can multiply this negative with that negative because there is no exponent that is besides 1 that is outside this negative 1. And it has no effect. So we can times the negative and get positive 1. Plus k is equal to 0. So we ultimately have 3 times 1, which is 3 plus 1 plus k is equal to 0. We transpose everything over to the right hand side and we get a k value of negative 4. Guys, I hope we are seeing this. Do you guys see this? Is it clear for all of us? All right, let's go back again to the question. This was saying if one root of an equation 3x squared minus x plus k is equal to 0. Now imagine, guys, if we did not know what this word means, this one, would we have been able to make the connection that this root simply means a solution of an equation? And therefore, because x is the predominant variable, it therefore means that the root is represented by x and its x is equal to negative 1. If one of the roots is negative 1, we need to find k and the other root. We've just successfully found the value of k by doing what? Taking the root, which we represent as x is equal to negative 1, then substituting x is equal to negative 1 into the equation, then allowing us to leave one variable k to solve for, which we were able to then use our algebraic skills and manipulation to get k is equal to -4. Not forgetting BEDMAS, because we would not dare take the 3 and multiply into the -1 without focusing first on the brackets B for BODMAS, in BODMAS, E exponents BEDMAS, and then later on multiplication of 3 and the applied exponent to -1. Then the negative times the 1, which gives us +1, ultimately transposing or moving the terms to the right with the sign change and k being equal to -4. Now, we are not done, because the question was find k and the other root. So, we now have found k, which means this equation can now be written completely with the value of k inserted. So now we can confidently go and write 3x squared minus x. Remember, k is now, we substitute what? -4 is equal to 0. What are we doing here? We are substituting k is equal to -4. Where? Into the original equation. So we can do what? So that in that way we can establish what the standard form of the equation is. Look at that. Isn't that in standard form? In the form ax squared plus bx plus c is equal to 0? Yes, it is. Then what do we do after that? We can then solve for x by what? By factorizing. And most of you should already know that one of the roots was actually -1, right? In other words, x was equal to -1. But when we factorize, okay, which we can do very confidently, we can place x plus 1 as one of our factors very confidently. So why? Because remember, if the root is x is equal to -1, we can actually write this as x plus 1 is equal to 0 if we are looking at the factor bracket. Does that make sense? Take the -1, transpose it, it becomes x plus 1. What do you leave on the right hand side? 0. I hope you guys understand this. So if I took -1 and I transpose it, I get x plus 1. But what do I leave on the right hand side? 0. So that's why I'm saying when you factorize 3x squared minus x minus 4, one of your roots that you had gotten was that you had actually stated was x is equal to -1. But in factor form, what is x is equal to -1? It's x plus 1. So without even using a quadratic formula or even trying to figure out the factors, you can simply put in the x plus 1 as one of your factors, because you know x is equal to -1 is a root for this equation. Then of course 3x times the x would give you x squared. And then of course, what would give you -4? What constant term would you have to multiply here by 1 to get -4? It would have to be -4. I hope that makes sense, and I hope you guys understand why it is like that. And no, you can quickly check this to verify and check that does it give you back this equation as it stands. And I'm sure you guys can see now that when you solve for x, you can now tell me what the other root is, because what are you going to do? You're going to take this one, which you haven't gotten the root of yet, and then you are going to solve that. You take the -4, you transpose that, then you divide both sides by 3, you get x is equal to 4/3. Guys, this is the other root you were looking for. That is what they were also looking for additionally. They wanted the value of k, which you found very well and nicely. And then now, by substituting that k value into the original equation, you were able to factorize. Once you got to standard form, you got your factors, you got you applied the zero factor law, and then you got the equation. which is, the root, the other root, which is x is equal to 4 over 3. It's obvious that for x plus 1, you are definitely going to be getting x is equal to negative 1, which you've already known is the other root for the equation. So guys, does that sound, are we feeling it? Okay, so this is how we go about answering questions with regards to when we are given a root and an incomplete equation. We simply use that root, substitute, get the unknown, and then we get that equation in standard form. We factorize it, we solve, we get the other root. Done and dusted. So I refer to that as type 1. Being given one root and being asked to find an unknown, a particular unknown. In this case, we had a k that was unknown. And additionally, the other root. That's how we go about it, guys. And we simply use our conceptual understanding of what a root is to be able to inform the steps that we take. We substitute the root into the equation. We solve for the unknown other variable. We take that unknown other variable, substitute it back into the equation that was given, and then solve for x to get the other root. And I hope that's clear. Monareng, you are amazing. Thank you so much for the roses. I really appreciate them. I saw them. It's just that I didn't want to break the explanation of the problem. Okay. Any questions, guys? The network's still treating us well? No glitches yet? No funky stuff happening yet to the network? Are we still audibly hearing everything? Explanations pristine and clear? Excited? Jubilation? Are we good? Can I move? Can we go to the next type? Okay, for Tlotlo it was lagging, so I have changed it up a bit. Is it better, Tlotlo? I hope I'm saying your name well. I'm saying your name okay. I'm not butchering it too much. Okay, are we good now? Is the lagging better? Okay, that's fine. It's funny, I always laugh at these people that say, please make another example. No, I won't do that. Letaba, look at this. Letaba, I'm going to go back to the same concept, okay? This type 1 of finding a quadratic equation from roots is simply a situation when I'm given one root. So there's a particular root that I'm given, okay? And remember, what did we say a root is? A root is simply a solution of an equation. And as we are given one root, we are asked to what? To find an unknown, usually represented by another letter, not x, and the other root. Okay, this is grade 11. All right. So the thing then is, we have this question. It says, if one root of an equation 3x squared minus x plus k is equal to 0. Yes, pure maths. Is negative 1. Find k and the other root. So, we are given one root of which equation? This equation. What is the root? It's x is equal to negative 1. It's negative 1, we are told. But we know immediately that we can actually say x is equal to negative 1. All right. Juice World 999. You know, that's beautiful. I like what you are saying. Juice World is very inspired, saying that pure maths is a quick way to go to Jesus. People see their absolute nothingness when they are doing mathematics. They see that this thing, it's something that does not need simple human effort. It needs the Lord and his intervention. I love what Juice World is saying. It makes you humble. It makes you dependable on a higher being. That's the one time that individuals actually see the need for a divine power. So, guys, don't take lightly what Juice World has said. But Juice World, hopefully this is not a negative sort of like comment, derogatory term or derogatory statement. But you mean that in the best way possible. So guys, let's take positivity from these words. I know Joswell was casually typing, but he did not know that he was being utilized for divine purposes. Joswell, I think the church needs you tomorrow. Please go to Jesus very quickly. Hey, let not maths be the only avenue through which you are become united as one with Jesus. And I hope that applies to all my learners on the platform. It can't be the only avenue. We need to just come, humbly as we are, instead of waiting for maths to humble us. No, you didn't offend anyone, Joswell. Sometimes it's very needful that these comments be said so that we can gauge. I try to extract positive things from all comments that come through in the live session. But hopefully those comments are not meant to sort of like put a spin of negativity for my learners who are so adamant, eager to learn and to sort of like really grab a hold of the mathematics. But thank you so much, Joswell. You are truly juicy. You are motivating us a lot. Thank you. Keep on drinking some juice there, in that world of yours. 999. You know what I mean? All right, let's go, guys. Let's move. So I was saying, given one root, which is -1, we substitute, we take that -1. It is a root of this equation. So we know a root is a solution. So we say x is equal to -1. We just put it in there into the equation. Okay, put it in there. We substitute that x is equal to -1, and then there's the substitution into the equation, guys. That way we are able to do what? Find the value of k. There it is. Okay, all of this applying our knowledge of BEDMAS. Okay, then after doing that, after we get the value of k, we then go and substitute it back into that original equation, and in that way we are able to then get our equation in standard form. We factorize it, we find the roots, and you'll quickly see that that root that you initially were told is the root of the equation should show up. It should show up, because if it doesn't show up, then it basically means that something has gone amiss. But it clearly does, right? And we get the other root as well, which in this case is x is equal to 4/3. So guys, I hope you guys really feel that question. And even my student there earlier on that was saying, can you do another one? Guys, sometimes it's not really needful to do another one more than it is important to grasp the concept behind a particular question. Because once you grasp that, then you are able to apply it in any problem. So this is type 1 question of being given one root and being asked to find an unknown, another variable, and then the other root as well. So let's proceed. Let's look at another type of question that we can be given under the topic find a quadratic equation from roots. Okay, let's look at this one. There are situations or scenarios. Okay, there are situations and scenarios like this one. When you are given roots of an equation and you are asked to find the equation in this form. Do you see this, guys? When you are given roots, you get given some roots of an equation, and then they ask you to find the what? The equation. And you have to represent it in this form. ax squared plus bx plus c is equal to 0. Let us look at an example. Look at this, guys. Look at this. Find the equation whose roots are 1, -2, and 3. We need to find the equation whose roots are what? -2 and 3. Just check, guys, how beautifully easy this is. So -2 and 3 are the two what? Roots. So for -2, let us write the root. It would be x is equal to -2, right? Then for 3, it would be x is equal to 3. Hopefully you guys can see. Now it's like we're working backwards, guys. So from the roots, see ya. Type 2 questions are situations where we are given the roots of an equation and we are asked to find the equation in this form: ax squared plus bx plus c is equal to 0. Right? So that is the type of question, type 2. When you are given roots of an equation and then asked to what? To find the equation in this form: ax squared plus bx plus c is equal to 0. So let's look at a specific example now, right? So hopefully, Sia, you've heard what the type of question requires. We are given 2 roots and then we are asked to express the equation using those 2 roots. So let's look at a specific question now. This is grade 11. Find the equation whose roots are -2 and 3. We need to find the what? The equation whose roots. What are the roots, guys? The roots are -2 and 3. Okay, let's look at this. So if one of the roots is -2, then it means x is equal to -2. Can we agree on that? Do we agree, guys? Hopefully we can see that. If one of the roots is -2, it means x is equal to -2. And then if the other root is 3, it means x is equal to +3. Hopefully we all see and understand that. Now, like I said, it's like we're working backwards. From the roots, we move on to the factors. This x minus 2, if I transpose the x minus 2 to the left, I get x plus 2 is equal to 0. Are we together? And that side, we get x minus 3 is equal to 0. Hopefully we all get that. Okay, do we see that, guy? Do we see that? That 0 factor law step. Okay, that 0 factor law step. Can I ask the people that are asking me about grade 9 to stop spamming the comment section, please? All right, I'm busy with grade 11 right now, and can we please do that? I do not know at the moment about grade 9, so yeah, because I'm focusing in grade 11 right now. Okay, so please let us not embellish the comment section with grade 9. Okay, x plus 2 is equal to 0. X minus 3 is equal to 0. Are we together, guys? So far. Okay. Then, the factor stage, x plus 2, x minus 3 equal to 0. We're going backwards. Do you see this, guys? Going backwards. We are going backwards from the roots to the 0 factor law to the factors. Now, we need to apply our grade 10 FOIL, meaning we are going to multiply x and x, which gives us x squared. Then we multiply x and -3, we get -3x. Then we multiply 2 and x, we get +2x. And then last but not least, we multiply 2 and 3, we get -6, which is equal to 0. I'd say we're very close to getting the actual equation for these 2 roots. Don't you think? Final answer. X squared minus x, because you add the like terms, then -3x plus 2x. Please, guys, let's not butcher the addition of like terms here. We keep the variable x. We add and subtract the coefficients. -3 plus 2 gives me -1. So it's -1x minus 6 is equal to 0. See the equation, guys? That is the equation we were looking for. X squared minus x minus 6 is equal to 0. Now, wasn't that nice and beautiful? Okay, so when we are given the 2 roots, okay, when we are given 2 roots and we are asked to find the equation, then we know what we ought to do. We write first and foremost our roots. Since we are told it's -2 and 3, it means x is equal to -2, and then there's the x is equal to 3. Then we move them to zero factor law. Okay. Okay. Yes. Yes. I love that. Hi, man. I absolutely love your comment there. I love this comment. This comment. It's like we're playing snakes and ladders, eh? Yeah. Sometimes you move forward. Sometimes you have to go back. I absolutely love this comment. This comment captures the essence of my channel. Comments like this make me realize that learners are actually feeling the game. It's all about the game. Yeah, that's what I'm talking about. I love that comment. I absolutely love this comment. Like, it makes me so giddy with joy. You know, I love it. I absolutely love it. Okay. Yeah, www.tiktok.kk.z. Yeah, it's got a blue cross there. Sorry, Bible cross there, doing the things, eh? I think that actually is a nice follow up to my Jesus brother there who was saying maths will send you straight to Jesus. It seems like Mr. Cross here has got some. Maths is really a game. Sometimes we have to go backwards in order to win. No, totally. Totally, I agree. I agree. Feel you there. Feel you there. Thank you so much for that comment. So refreshing. So full of life. All right. Okay. Let's look at another question, guys. Look at this one. Look at this one. Thank you so much for your comment. Really appreciate it. Eh? There we have it. B, guys. Look at this one. Same thing. We are told to find the equation whose roots are half and negative 5. Let me give you guys a chance to do this one. Let me see what you have cooked up in the pan. 2 roots, x is equal to half, and negative 5. Okay, so let's see if you guys are able to move backwards. Let me give you a beautiful 5 minutes to sort of like, bust out that sweet pen that you have in front of you. Bust out that sweet book that you've been using, the one that is like a maths is a game, sort of like maths grade 11 book that you are using on the side because you're supplementing all the maths, like you all obviously have the one that you use at school, but you have this one that supplements your goodness. And yeah, it's just all bringing all these things together, man. Okay, so find the equation if the roots are half and negative 5. Okay, remember that we've just come from this question where we were given the roots are negative 2 and 3, and we worked all the way sweet backward, and we were able to find the equation. The equation is x squared minus x minus 6. Let's go here. Let's find the equation if the roots are half and negative 5. All right, and it's 5 minutes, so a minute has passed. Definitely, I'm hoping that someone within this space, okay, not necessarily now, you won't tell me the answer now of what you got, but as we proceed, I will open up a time and I'll say, please type your answers, then you can go ahead, and I just want to see what people have been able to get as they've been doing the problem in their space. Okay, so I wait patiently. Okay, we have 1 more minute left. 1 more minute left. One more minute left. Okay, guys, you are more than welcome. Let us type in the comment section what we got as our equation, because I'm hoping that people have been able to do this. They were able to get an answer. Please let us type our comment. Comment, please, in the comment section. Let me know what is the equation that you got for when the roots are half and -5. What did we get? Let's go. Let's go. Let's go. Let's go. Let's go. Let's go, let's go, let's go, let's go, let's go, let's go. Okay, I see my sir there has got an equation. I see it is very fractiony. Okay, right, that's one attempt. What does someone else have for me? Oh, okay, Tsala is getting there. All right. Yeah, so remember, guys, there is another element here when we do the mathematics. It's the whole idea of time frame. Okay, me and you have to get so better at having mastered the content that it sort of like sorts out the time which I spend doing a problem. Okay, most learners really complain oftentimes about time when they are writing tests, mathematics tests, and oftentimes that problem is there because of maybe not doing some more problems so that you can eventually, slowly but surely, get to a place where, because of doing those problems consistently, you can be able to get the answer. Tsala, the question was asked, didn't you write down the example? All right. Remember, guys, as I teach, I think you guys are doing yourselves a very big disservice. If you simply come into this live session and you simply come here and you are listening and that's it, there is no book, there is no pen, there is nothing in front of you, and you are really literally treating this as if you are watching one of those live sessions that you usually watch that are not maths related, where you don't need a book and you simply are just watching some content on TikTok, and that's it. Okay, then it kind of makes me a bit sad. Okay, so let's make a concerted effort, because remember, this is all a build up. I'm setting you guys up, like I am so setting you guys up. All right, I understand, Zala, you say you came late. Okay, which is okay. So we can have a bit of mercy upon you.